Hello students, in this video I am going to start sums of chapter 13, that is surface area and volumes, from class 10 MBOSE textbook. Basic formulas of this chapter I have explained in the part 1 of chapter 13 in class 9 videos. You can first watch that video, then you can start this chapter. In 13a, question number 1 is, two cubes each of volume 27 cm cube are joined end to end to form a solid. Find the surface area of the resulting cuboid. Suppose in this cube each edge is x centimeter, so we can write let each edge of the cube be x centimeter, and as given in the question, volume of each cube is 27 centimeter cube, so x cube, because we know volume of a cube is side cube, here each side is x, so x cube is 27, so x will be cube root of 27. 27 is 3 cube, this 3 and the cube will cancel, so we are going to get x equals to 3. Since x is 3, so when two cubes are placed side by side, this is 3, this is 3, so total length will be 6 cm. Breadth will remain 3, height also will remain 3, only length will become 6 cm. So in case of resultant cuboid, we can write length equal to 3 plus 3, 6 cm, breadth equals to 3 cm, and height is 3 cm. As we have to calculate the surface area of the resulting cuboid, we know total surface area of a cuboid formula is twice LB plus BH plus HL. So it will be twice L into B, 6 into 3 plus 3 into 3 plus 3 into 6, twice 18 plus 9 plus 18. If I add this 3, it will be 45. 45 to the 90. So 90 centimeter square is the surface area of the resultant cuboid. In question number 2, it is given the volume of a hemisphere is 2425.5 centimeter cube. Find its curved surface area. Now suppose this is the hemisphere and radius is r. We can write let r centimeter be the radius of the hemisphere. We know volume of a hemisphere formula is 2 by 3 pi r cube, and as given it is 2425.5 centimeter cube. If I multiply 2425 into 2, it will be 4850 plus 1, that will become 4851 by 2. So if I convert this mixed fraction into a normal fraction, it will become 4851 by 2. So 2 by 3 pi r cube is 4851 by 2. 2 by 3 pi is 22 by 7 into r cube is 4851 by 2. So r cube will be 4851 by 2. If I cross multiply, this 3 and 7 will go in the numerator. 2 and 22 will come in the denominator. If I cancel by 11, 11 2 ja 22, 11 c, it will be 441. So r cube is 441 into 3 into 7, 21 by 2 into 2 into 2. So we can write r cube is 441 is the square of 21. We can write 21 into 21 into 21 by 2 into 2 into 2. So r cube will be 21 cube by 2 cube, which can be written as r equal to cube root of 21 cube by 2 cube. Cube and cube root will cancel. As a result, we are going to get radius equal to 21 by 2 centimeter. Now in the question it is given we have to find the curved surface area, and curved surface area of a hemisphere formula is 2 pi r square. So 2 pi is 22 by 7, r square, r is 21 by 2, 21 by 2 into 21 by 2, 7 3 ja 21, 2 and 2 can be cancelled, 2 11 ja 22. So it will be 11 into 3 into 21. If you multiply, it will be 693. Therefore, 693 centimeter square is the curved surface area of the hemisphere. In question number 3, it is given if the total surface area of a solid hemisphere is 462 centimeter square, find its volume. Suppose the radius of the hemisphere is r, so we can write let r centimeter be the radius of the hemisphere. In the question it is given total surface area of the hemisphere is 462. Total surface area of a hemisphere formula is 3 pi r square. If it is curved surface area, it will be 2 pi r square, and if it is total surface area, it will be 3 pi r square is 462. So 3 pi is 22 by 7 into r square is 462. So r square equals to 462. This 7 will come in the numerator, 3 and 22 will be in the denominator. Now if I cancel by 11, 11 2 ja 22, 11 42 ja, so r square is 42 into 7. 42 into 7 by 3 into 2. Again, we can cancel 2 and 42, it will be 21. 3, 7 ja 21. So r square is 7 square. That means r equal to 7 centimeter. As given, we have to find the volume. So volume of the hemisphere is 2 by 3 pi r cube. 2 by 3 pi, pi is 22 by 7 into r cube, 7 into 7 into 7, these 7s can be cancelled. So 2 into 22, 44, 49 by 3. Since it cannot be cancelled, if you multiply these two, 44 and 49, it will be 2156 by 3. If you divide, it will be 718.666 centimeter cube. If I round off, it will be 718.67 centimeter cube, which is the required volume of the hemisphere. In question number 4, it is given a 5 meter wide cloth is used to make a conical tent of base diameter 14 meter and height 24 meter. Find the cost of cloth used at the rate of rupees 25 per meter. So this is the cloth. Length is not known and breadth is given 5 meter. This cloth is used to make this tent, which is in the shape of a cone. Here it is given height is 24 meter and diameter is 14 meter. Now we have to find the cost of the cloth at the rate of rupees 25 per meter. Now in case of this cone, here diameter is 14, so radius will be half of 14, that will be 7. Here height is 24, but we know curved surface area of the cone is pi r l. Here L is not known, so we have to calculate L. For this we have to use Pythagoras theorem. So here radius is 7 meter, height is 24 meter, slant height will be L equals to root over h square plus r square. So 7 square plus 24 square, 49 plus 576. If I add, it will be 625, which will give 25, because 25 square is 625. If we take square root of 625, it will give 25. Now curved surface area of the tent, that is pi r l. Pi is 22 by 7 into 7 into 25. 7 can be cancelled, so it will be 550 meter square. So curved surface area of this tent is 550 meter square. That means area of the cloth also must be 550 meter square. And area, since it is a rectangle, so area will be length into breadth. So we can write, let length of the cloth be L meter, breadth already we know 5 meter. Now area of the cloth, from the calculation we got 550 meter square. L into B 550, B we know 5. So L into 5, 550. So L is 550 by 5, which will give 110 meter. So we got length of the cloth 110 meter. In the question it is given per meter cost is rupees 25. Therefore cost of the cloth is 25 into 110, which will give 2750. Therefore cost of the cloth used in preparing the cone is 2750. In question number 5, it is given that a military tent of height 8.25 meter is in the form of a right circular cylinder of base diameter 30 meter and height 5.5 meter, surmounted by a right circular cone of the same base radius. Find the length of the canvas used in making the tent if the breadth of the canvas is 1.5 meter. So here lower part is a cylinder and upper part is a cone, and this one has to be covered using a cloth whose length is not known and width is 1.5 meter. Now in this case, if you want to find the total surface area, we have to find the curved surface area of the cone plus curved surface area of the cylinder. To prepare this tent, we have to give the canvas in the upper part and in the side. In the lower part, it is not required. In case of cylindrical part, diameter is 30 meter. Since diameter is 30, so radius will be 30 by 2, which is 15 meter, and height is 5.5 meter. Now in case of cone, here diameter is 30, so diameter of the cone also will be 30, so radius will be 15, and here height of this cone will be 8.25 minus 5.5. So we can write, in case of conical part, radius is 15, height will be 8.25 minus 5.5, which will give 2.75. Since curved surface area of a cone is pi r l, and here L is not given, so we have to calculate L by using this Pythagoras theorem. So L will be root over h square plus r square. H we know it is 2.75 square, radius is 15. So if I square 2.75, it will be 7.5625 plus 225. After adding, it will be 232.5625, which will give 15.25 meter. Now surface area of the tent will be curved surface area of the cone plus curved surface area of the cylinder. In case of cone, formula is pi r l, and in case of cylinder, it is 2 pi r h. From these two I can take pi r common, it will be L plus twice h. Pi is 22 by 7 into 15. L, we got 15.25 plus twice h, 2 into 5.5. So 22 by 7 into 15. 15.25 plus 5.5 into 2, it will give 11. So 22 by 7 into 15 into 26.25. If we cancel 26.25 by 7, it will be 3.75. So 22 into 15 into 3.75. If I multiply this two, it will be 330 into 3.75. After multiplying, we got 1237.50 meter square. Since tent is prepared from the canvas, that means total area of the canvas also must be 1237.5 meter square. Now length of the canvas is not given. Let L meter be the length of the canvas and breadth already given 1.5 meter, and we know area of the canvas must be equal to 1237.5. So we can write here area of canvas needed is 1237.5. Length into breadth is this much. Length into breadth is 1.5 is 1237.5. 1.5 can be written as 15 by 10, and if I cancel by 5, it will be 3, it will be 2. So L into 3 by 2 is 1237.5. So L equal to 1237.5 into this 2. If I cross multiply, it will come in the numerator and 3 will be in the denominator. After cancelling this by 3, it will be 412.5. So length will be 412.5 into 2, which will give 825 meter. And as given in the question, we have to find the length of the canvas. So 825 meter is the required answer. As question number 6 is almost same as question number 5, so I am not showing. Let me show question number 7. Here it is given a circus tent is cylindrical to a height of 3 meter and conical above it. If its base radius is 52.5 meter and the slant height of the conical portion is 53 meter, find the area of the canvas needed to make the tent. Here it is given this radius is 52.5. From here to here it is 52.5. Height is 3 meter. And the slant height is given 53 meter. So here directly we can write in case of cylindrical part, radius is 52.5 and height is 3 meter. In case of conical part, radius will be same. So here also it will be 52.5 and slant height is 53 meter. As we have to calculate the area of the canvas, we have to find the curved surface area of the cone plus curved surface area of the cylinder. So we can write area of canvas needed to make the tent, curved surface area of the cylinder plus curved surface area of the cone. Curved surface area of the cylinder is pi r L and curved surface area of the cone is 2 pi r h. Pi r common, so it will be L plus 2 h. Pi is 22 by 7 into radius is 52.5. L given in the question 53 plus 2 into h, 2 into 3. 52.5 can be cancelled by 7. It will be 7.5. So we got 22 into 7.5. 53 plus 3 to just 6. 22 into 7.5. After adding this, it will be 59. So if we multiply this, we are going to get 9735 meter square, which is the area of the canvas needed to make the tent. In question number 8, it is given a solid is in the shape of a cone mounted on a hemisphere, the radius of each of them being 3.5 centimeter and the total height of the solid is 9.5 centimeter. Find the volume of the solid. So in this solid, total height is 9.5 centimeter. This radius is 3.5 and we have to find the volume of this solid. So in case of hemisphere, radius is 3.5. In case of cone, radius is 3.5 and height will be 9.5 minus 3.5 because this part will be 3.5. So 9.5 minus 3.5, which is 6 centimeter. As we have to find the volume of the solid, it will be volume of the hemisphere plus volume of the cone. So we can write volume of the solid is volume of the hemisphere plus volume of cone. Volume of hemisphere is 2 by 3 pi r cube plus volume of cone is 1 by 3 pi r square each. Now from this two I can take 1 by 3 pi r square common. From here we are left with twice r plus from here already 1 by 3 pi r square I have taken common, h is left. So 1 by 3 into pi is 22 by 7 into r square, radius is 3.5, we can write 3.5 into 3.5 plus twice r, 2 into 3.5 plus h is 6. Now 3.5 to the 7, so these two can be cancelled. 1 by 3 into 22 by 2 into 3.5, 3.5 into 2, 7 plus 6. 22 and 2 can be cancelled, so we'll get 11. So 1 by 3 into 11 into 3.5 into 13. If we multiply all the numbers in the numerator, it will give 500.5 and the denominator it is 3. After dividing, it will give 166.83 centimeter cube. Therefore, the volume of the solid is 166.83 centimeter cube. That's all for today. In the next video, I'm going to start from question number 9.